In this video, we're going to learn how to solve exponential equations using logarithms. So as we solve each exponential equation, we'll express all irrational solutions in exact form and as a decimal rounded to 3 decimal places. So in order to solve an exponential equation, we actually can just reconvert this into a logarithmic form, because in logarithmic form, the exponent is by itself, and it's equal to a logarithm with the same base as that exponent, and then of the other side, 5. And there you go. X is equal to log base 2 of 5. Because again, x is the exponent you raise 2 to get 5, like it says above. And there we are. We're done. Now, an alternative way to solve this is just to take the log of each side of the equation. So we'll have log of 2 to the x is equal to log of 5. Now we'll use the exponent rule. We'll move that x out in front as a factor, that power, giving me x log of 2 is equal to log of 5. We can divide each side by log of 2, and we'll get log of 5 divided by log of 2, which is also a correct solution. And if you notice, this is just a change of base formula away from the previous solution. Now, what is this decimal? Well, we're going to use the change of base formula because that's possible to plug into my calculator. So log of 5 divided by log of 2. And that gives me approximately 2.31, and then 32, then rounded properly to the third decimal place, 322. So here's a decimal approximation of the answer, and here's two versions of the same answer. But let's look at the next one. We have 8 times 3 to the x equals 5. So if I want to solve this, I first need to get the exponential part by itself. So I'm going to divide by 8. So I'll have 3 to the x is equal to 5/8. And then I could just simply rewrite this in logarithmic form, give me x is equal to log base 3 of 5/8, which is, granted, a viable solution. But let's go over the alternate way to solve this. It would be to take the log of each side after you divide it by 8. So we have log of 3 to the x is equal to log. Actually, just to try something different, let's try doing it with natural log instead. Just so it's a little bit different than the previous problem. Because truly you should be able to use either one. The reason why I'm using natural log and log is because those are keys on my calculator. So I want to show you that the solution can work either way. And then we can move the exponent out in front, giving me x natural log of 3 is equal to natural log of 5/8. Then I can just divide by natural log of 3, and x will equal the natural log of 5/8 divided by the natural log of 3. Which, if you notice here, is still the change of base formula away from the actual answer over there. So either of these solutions work, but I'm going to have to use the right solution in order to plug it in. So natural log of 5/8 divided by natural log of 3 gives me negative 0.428 when I round correctly. So it truly doesn't matter if you use log or natural log. Using one of them is a viable way to solve the problem. Let's look at the next one. Here we have both of these exponential bases raised to variable powers. And the reason why we've been using logs, in case you haven't noticed, there's no way to pick a perfect power to raise 2 to get to 5, which has no factor of 2 in it. And this is why we're using logarithms. So here they both have variables. So in order to solve this one, I'm actually not even going to consider rewriting, because rewriting the logarithm would still put an x within the other logarithm, which puts me on a logic loop trying to solve it. So in order to solve this problem, I'm going to have to use this technique I've been using secondarily, in the other two problems. So I'm just going to take the natural log of each side. And now I can move those powers out in front of those logarithms. So I'll have x minus 2 times the natural log of 5 is equal to 3x plus 2 times the natural log of 3. And now I want to combine my x's on one side of the equation, but in order to do so, I have to distribute these natural logs into those parentheses. So I'll get x natural log of 5 minus 2 natural log of 5 equals 3x natural log of 3 plus 2 natural log of 3 when I distribute. Now I'll move all my x's to one side and my constants to the other. So I'll subtract 3x to the left. So I'll have x natural log of 5 minus 3x natural log of 3. And then I'm going to add 2 natural log of 5 to the right side to give me 2 natural log of 5 plus 2 natural log of 3. And now to get x by itself, I can factor it out of the left side of my equation. Give me x times the natural log of 5 minus 3 natural log of 3 when it gets factored out. And on the left, I could also just factor out a 2 out of that expression on the left since they both have a 2. And then I'll divide each side by natural log of 5 minus 3 natural log of 3. So x will equal 2 times natural log of 5 plus natural log of 3 over natural log of 5 minus 3 natural log of 3. So that is the exact solution, and as you can see, this does not obviously look like a logarithm in change of base form. So it's a very unique solution. But what is the decimal approximation of said solution? We'll put in 2 times, let me put that in parentheses, 2 times the natural log of 5 plus the natural log of 3 and then divided by the natural log of 5 minus 3 natural log of 3. That gives me x is approximately negative 3.212 when rounded correctly. So this might be a better looking solution here is because I don't really know the value of that just looking at it, but I'm like, oh, that's about negative 3. Now for this last one, it's going to be hard to solve this because I can't put an exponential each side of the equation because I still have this 12 that doesn't have an exponential or a variable in its exponent. But one thing I'm noticing here is that 4 and 2 are both powers of 2. So I could start this problem off just by writing it as 2 squared to the x minus 2 to the x minus 12. And something curious happens here because this 2 squared to the x, if I were to swap the positions of the x and that 2 using that commutative property, I know the powers are going to multiply. I can get 2 to the x squared minus 2 to the x minus 12. And if I just I'll pick another variable. Let's say u equal 2 to the x. What happens is I get u squared minus u minus 12. And that is a quadratic that's very easily factorable. And it'll be u minus 4 times u plus 3 equals 0, which really means for me, on the left, I have this can be factored into 2 to the x minus 4 times 2 to the x plus 3 is equal to 0. So I can actually factor these exponential equations if they're quadratic in form. And then I can say each factor equal to 0. On the left, I'll get 2 to the x equals 4. And I know 4 is 2 squared. So x is equal to 2 as one solution. But on the right, as I go to solve, I can subtract 3 and get 2 to the x equals negative 3. which if I try to finish solving, I can take the natural log of each side. Natural log of 2 to the x equals natural log of negative 3. Giving me x natural log of 2, and I move the x out in front. But already I'm noticing a problem right here. X cannot equal this number because there's a negative within that natural log. So that is not going to give me a solution. In fact, I can notice this earlier, this exponential, when it equaled negative 3, was already an issue because exponential's range is all positive numbers. So this wouldn't have even worked earlier either. So I only get the solution of 2. And that is how you solve exponential equations using logarithms.